Alrighty, I've had some recording problems today, so I'm gonna leave. We'll do this one just a little bit differently as far as the notes are going to be done, and I'm just going to highlight and point to the things that we need to be cluing in on to do our homework today, or in this last section. So here's our last little bit. Again, a poll was taken from Gallup. It asked 1,006 national adults whether they were baseball fans. If we highlight this, the 48.4 and the 1,000 national adults hold the important part. This is just extra information. We're going to find the margin of error for that 2012 poll at 90% confidence. So in creating a confidence interval, my calculator is going to do the bulk of the work for me. And if we were taking this in class, we would talk about the equation and how we would work with the margin of error part of the equation. But here, I think we're just going to use our calculator and some calculations with it and just roll with it. So this one's a unique one because they gave me a percentage. When it gives me a percentage, my calculator is going to need to know a specific value of X. So we're going to take that percentage times my sample size, and we're going to get 487 successes. There was 1,006 in the trial, and then I want to be 90% confident. Okay, so if we flip back over to my calculator, that is not my calculator. That's not the calculator either. How about there? Okay. Now that I've back, that's okay. Anyway, stat. When we go over to stat, we're going to arrow over to tests. We're going to go down that test column until we get to a 1 prop Z interval is what we're trying to do here. And here's the information that we have. So I believe we're starting out with the baseball problem. And so if I remember the stuff from the other page, it's 487. Successes, 1,006. We're actually in the sample. And we're going to strike out at 90% confident, we're going to hope. And then we're just going to hit enter. And that's going to give me all the things that I need as far as to calculate that. Okay, something seems amiss here from what I have. Nope, there it is. Sorry, I found it on my paper. So the 458, I can't point at anything now because my pointer only works in the app. So we're going to jump out of this. We're going to jump back to that. And so this was the interval here that my calculator spat back out at me. And so this gives me the left boundary and the right boundary of the interval itself. Now I want to create a margin of error. So the proportion in the middle is going to be this guy right here. The 484 was the proportion in the middle, and then we had a margin of error that went to the left and a margin of error that went to the right. So really to find that margin of error, we're just going to find the distance across my interval. So we're going to subtract those two values, divide that in half, and so 0.259 was going to be the margin of error there just by some calculations versus working with the equation itself. Now, what does that mean? Well, it means that we are, again, 90% confident that the poll estimates are within 0.0259 plus or minus of the true proportion of baseball fans. So, again, if we're explaining the margin of error versus explaining a confidence interval, those are two different things. Okay, if it was a confidence interval, it'd be we captured it 90% of the time. If we want to be 99% confident, so that means that we, again, the wider I make it, the more confident I am that I captured the true proportion. So we're going to go from 90% up here, 90% up here to 99%. So that means that we're going to make my interval wider. So that means that my margin of error has to be wider or larger in order to make my interval wider. So then we would go over to my calculator. I would type in the same exact things, except I would change in the 99% confidence interval to change the 90 to a 99. And this is the new interval that it created. Okay. Now we can see then it went from 45818 back to 44351. So it went back another 1.5%. And then it went up another 1.5%. So we can see that again with the same process, we find the distance across. So we can see that my margin of error almost doubled by changing it to a 99% confidence interval. Okay. So in general, if all their aspects of the situation remain the same, smaller margins indicate less confidence. Okay. Moving on to the next one, an insurance company. Checks 560 accidents and notes the teenagers were behind the wheel in 97 of those. It wants us to create, again, if we highlight what it wants, it's 95% confidence. The X value it told us was 97 on this one, so we didn't have to multiply it with the percent. And we got a grand total of 560 in that. So the only thing that we have to do on number 7 here is create. No, never mind. There's A, B, and C. I don't know what I'm looking at. So here we go. 97, 560, and 95% confident. So if we flip back over to my calculator, again, we're going to go stat. We're going to go over to test. We're going to arrow down to that 1 prop Z interval. Okay. And as we were doing this, the insurance company, it was 97 out of the 596. And we were going to be at 95% confidence. So it's just, again, this is very calculator driven. It's doing all that fun stuff in the background for us that we don't have to worry about. Anyway, I get 13.3 to 19.2. So if we scroll over, there it is. Again, if we looked at that percentage, if we go back to my calculator a little bit, we can see that it gave me a p hat in the middle, that 1627. That is the proportion in the middle. So that is it's called a p hat. It's where the center of my interval is, and then what happens is we're going to go a margin of error to the left and a margin of error to the right, and that is what creates the interval for me. So again, to find out if we're trying to create, here would just create the interval. So there is the interval. It's from 13.3 to 19.3, but that's how we would go about finding that margin of error, or explaining that a little bit. Anyway, explain what my interval means. Now, on all these today, I'm handwriting out most of the answers, but in reality, it's going to be multiple choice. So I left a couple of these in here as the multiple choice. So again, we're 95% confident that the true percentage of accidents involving teenagers falls inside the interval limits. Okay, so that's what we're looking for, and yours is going to be a different order potentially, but that's what we're looking for, is that true percentage. Okay. And what does the 95% confidence mean? So that means that about 95% of my samples of size 560 will produce confidence intervals that contain the true proportion of accidents involving teenagers. So again, this is a little bit different. You have the ability to pause, so versus write down. I'm not for sure how you've been doing it, if you've been doing videos at all. But anyway, here we go. Number 8. Okay. Wildlife biologist inspects 136 deer taken by hunters. 29 of them find carrying ticks that test positive for Lyme disease. All right, so again, since it wants us to create 90% confidence, Ford said that. We know that X is 29 and the other part is 136. And it's 90% confident. Okay, so again, this is all calculator driven as we go out to the calculator. Again, stat, we go over to test. We're going to arrow down until we get to that 1 prop Z interval. Okay, and again, successes, we had 29 deer test positive for Lyme disease out of the 100 and... I've actually lost it, 136 deer that were captured by hunters, or shot by hunters, and we wanted to be 90% confident. All right, so there it is. Again, we have a point estimate, so that was that 21% is in the middle, and then we got 15.5 on the left, 27.1 on the right. And so there's the interval that it would create. So we just took that information back here. P hat was unnecessary, but we needed the interval because that's what it wanted. Okay. If scientists want to cut the margin of error in half, how many deer should they inspect? So if we come over here again, it gets a little bit murky now that I've scribbled all over the notes, but what we're after here is, this is my equation to find a margin of error. The margin of error is this critical value times the standard error being p hat times 1 minus p hat all over n. Now we are wanting to cut the margin of error in half. Now since all of this is underneath the square root, my sample size is what's going to change. And because we ended up taking a square root of this number, in order to make this, to cut it in half, this needs to end up being a 2. So because it's a square root, it has to be the square root of 4, which turns into this 2. So working backwards, I have to take my sample size times 4, and that's the moral of the story. To cut my error in half, I'm going to take that original sample size times 4, and so 544 deer. So that was a long story to something that's actually very, very short. Okay. Now, do we have any concerns about this sample? And again, the concern is since we're depending on what our licenses were for, but a lot of times especially younger deer and females are less attractive, and so not hunted as much. So we would not necessarily know that population of deer collected by hunters would represent the entire population of all deer. Okay. Number 9, a medical researcher, we talked about beats per minute of the randomly selected adults. Now, when we get to 9, 10, and 11, and 12, the last 4, we are going to switch gears a little bit, okay? This is going to be over here in blue, okay? Now we're going to use a 1 sample T interval. All right, so now what we're going to do is, again, we have switched gears to a T interval because now we're going to be talking about a means. All right, so now we're going to be using an interval for means versus a proportion. So we have to change up what we use there, but the mechanics of it all is going to remain exactly the same. We were given with 90, if we go back to the pointer here, 95% confidence. We had a left boundary, a right boundary, and my mean is in the middle. So explain what this output means. We are 95% confident the true mean pulse rate lies between 66.5 and 70.9. So we're 71 when I rounded that. Okay. The margin of error, again, calculating the margin of error works the same way it did with a proportion as it does with a mean. So we find the distance across the interval. We're going to take that distance and then divide that in half, and that's going to give me my margin of error. It's 2.23. It's actually beats per minute. I don't think the beats per minute actually is part of that answer or necessary. So there we go. And then lastly on the question is, if the researcher had calculated 90, now pay attention to the problem that you get. I am going from 95 to 99. So I am becoming more confident. In order to be more confident that I captured the true mean, I'm going to have to make my interval wider. Okay, so therefore, to make my interval wider, my margin of error has to be larger. On your problem, you may end up shifting down. You may start with a 99 up here and come to a 90 here. In that case, your answer is going to be smaller because we're going to be less confident. So do pay attention to that when you're filling out your particular problem. Okay. In number 10, we're talking about hoping to lure more shoppers downtown. Again, this is going to be a T procedure because we're talking about 129 is my mean, 16 is my standard deviation, my sample size is 44, and those are all the different things that we need to do that. If we were going through these procedures for real, or if you had taken class, we'd have to go through a whole thing of assumptions that need to be met before we can do that. In this particular case, it's going to focus on two of those. Approximately normal, which means the distribution is unimodal and symmetric with no outliers. And as well, it came from a random sample of all weekdays. So those are the two things that we would have to check for assumptions on this particular one. Again, we're not going to hit that super hard. The general mechanics is what I'm worried about. And that's the road I decided to go down. Okay? All right, so when we go to do this, my sample size is 44. We had a mean of 129. We had a standard deviation of 16. And I want to be 90% confident. Okay? There we go. So let's see what this 90% confidence interval is. So let's slide out here. So again, we're going to go stat. We're going to go over to tests. And we are creating now, though, a T interval. So we're going to do a T interval. And we had all those different stats that we needed to write down. So that means that, we have our choice of data or stats. We need to make sure we pick stats. Data is going to be the list of actual collected that day or something like that. Okay, so that means it's going to be 129. That standard deviation was 16. The sample was 44 weekdays. And I believe we are going to be 90% confident we're going to collect that. So 124.95 to 133.05. Now here's what's different about that, because the one I calculated previously dealt with. I realize now that I printed off a version of your homework assignment so I could see what the answers were. But this was a 95% confidence, so things got changed. I just went off the key, and I should not have done that. So 124, what's that, 95 and 05. Okay. All right, so we got that cleaned up a little bit. Anyway, again, the process works exactly the same. There was a mean in the middle. The mean in the middle is 129, and then we had a margin of error each direction. Again, talking about what that is, we're 90% confident that the true mean income for the parking garage lies between 124, and actually I need to change that now too. 124.95 and 133.05. Okay, and explain what it means to be 90% confidence means the interval contain. We're 95% confident, the 90% confident that the interval contains the true mean. Here's a conclusion thing. We not a whole lot of these and the problems I assigned, but here's how we make conclusions with that. There's a consultant who advised the city that the parking revenue is going to be $142 per day. Now we can see that 142 is not contained within the interval, so therefore this interval provides evidence against the claim that the consultant has made. Now this ends up being, again, not something that we have to be able to write out, but we have to be able to read the right sentence and choose the right sentence. So this is a fill-in-the-blank thing. So since the confidence interval does not contain 142, the consultant's production is not plausible. Now, when you do yours, you may have that exact opposite. You may end up with a number that did fall in the interval, so it does contain, we strike out the not, and therefore it would be plausible. Okay, so be sure that you understand that difference when you go to do that. In number 11, again, we are having some summary statistics here for the daily body temperature. And it is, would a 90% confidence interval be wider or narrower than 98? So we're comparing 90 and 98. So again, 90 is going to be less confident, so therefore my interval will be narrower. And therefore, because we're going to be less confident at capturing the true mean, that's going to make my confidence interval narrower. Okay? What are advantages and disadvantages to the 98? The wider, the better a chance. So with 98, the wider it is, the better chance I have of capturing the true mean. However, if a narrower interval is more exact, okay, or more precise. If further research is conducted, this time we use a random sample of 500. How is the 98% likely to change? And again, this goes back to my formula. If I put a number that it was 46 up here, and now we're moving it to 500, so the denominator of this fraction has to get bigger. So as this gets bigger, that means this overall fraction gets smaller. So because my standard error gets smaller, that means that my margin of error also gets smaller. Okay? And the last one's going to be a little bit different style of problem than what we're used to. This one actually goes a little bit more mathy than I ever wanted to get, but it's here and we got to do it. I missed that. So here we go. We want the margin of error to be 0.1. So we have a formula for the margin of error. It looks like this. Okay? We're going to put the test statistic there again, and I didn't write this out. Maybe I should write them out somewhere. Maybe I went back over this. So if I am 90% confident, that means we're going to put a 1.64 in there. If I am 95% confident, this is where we're going to put the 1.96, which is what I put over there. And we won't worry about the other one. or get a different get a different problem that uses one of those two. One of the, I would suggest, if you can do that. Anyway, here we go. Again, we're just substituting. We know that that critical value is going to be 1.96. The standard deviation we pulled from up here. Here's my standard deviation, and as well, it's going to be 48. We're choosing what n is here. So here's where algebra kicks in. We're trying to get n by itself, so my first step was to divide out the 196. So when we did that, that's an 051. But when I had this equal fraction, we know that those two are going to can switch places, so that's why the square root of n comes out, the 051 goes underneath, and then we're going to square both sides to get rid of the radicals. So we get some number, 358 point something, but we're always going to round up, so that's why that number turned into a 359. And I don't know why why did these disappear? I don't know why. I thought I put these back on here. Anyway, our last problem here is, and I guess I wish that I had the opportunity to take this one off. I'm not a big fan of this problem either, but we'll live with it. The sample is neither a random sample nor suitable. That is the answer, the highlighted answer on this problem. I really don't know exactly where it after the accompanying histogram and summary statistics are provided for the percentage of flights departing on time each month, January of 94 through June 2016. There is no evidence of trend over time. So this is the number of months and the percent on time percentage. So this is tough because typically it's we use a mean for a t interval, and this is what these are supposed to be. And this is what we're going to have to use as far as we're going to use these as my summary statistics. Okay, so again, we're going to use a t interval. We are going to be 90% confident on this. Okay, and so find that 90% confidence interval. So when we slide over here to my calculator, we're going to go stat. We're going to clear. I don't know what we're going to do. You make up your mind. Test. We're going to go down to this t interval. Okay? And again, this t interval, we have our choice between doing data and stats. We're going to select stats. We have a mean. Now, because it was in the y direction, it was a y bar, but we're going to use that y bar off the other sheet. The standard deviation there was 0.5019. And my sample size is 270. And we're going to be 90% confident, so we're ready to calculate that. Okay, so that interval is 7808 to 7819. Did I type in something different? Because that's not what... sorry. I'm looking at my notes, and I have a different answer on my notes, so... That's why I want to make sure that we got this 78.133, 0.5019, 270, 90% confident. I don't know what I wrote down. And I flustered it again, and it's sitting there, unable to move, paralyzed. 7808 to 7819. So again, find that 90% confidence interval. It is 78.08 to 78.19. Okay, so we are 90% confident that the true proportion or the true mean of percent of flight times will be between 78.08 and 78.19. So actually a really narrow interval. Okay, and lastly, interpret the interval for planning to fly. Select the correct choice below. Again, I forgot to take that out. And again, all the way through this, you are just selecting. That answer is, there is a 95% chance, actually, not 95, ours is 90. There is a 90% confidence the interval that this interval contains the true mean monthly percentage. of on-time departures. All right. That wraps it up. All right, I hope you got something out of taking this class. I enjoyed putting it together, and hopefully it was worthwhile. Have a great day.